Let's go. What's up, everybody? Welcome to the Comet ML Office Hours. It is Wednesday, October 27th. Man, years going by quick, man. Shit's going by fast. A lot faster than last year, that's for sure, man. Hopefully, you guys are having a excellent week so far. I'm excited to be here with my colleagues Drew and Austin and my good friend Kristoff. We're here to help answer all of your questions related to machine learning, data science, deep learning. Well, you could ask all your questions. We may or may not have answers, but we will be able to point you in the right direction. So hopefully you guys got a chance to tune into the Artists of Data Science podcast. Last week, I released an episode with Emily Balchetes. We talked about her book, Clearer, Closer, Better. That was an amazing conversation. I really enjoyed speaking with her. This Friday, though, I've got an episode releasing with Andy Hunt, the legendary Andy Hunt, who is the author of The Pragmatic Programmer, amongst many other best-selling books. He dropped so much knowledge and wisdom in that conversation. So definitely looking forward to having that released and shared with you guys. Also, today in like 12 p.m. Central Time, so 2 hours after right now, I'll be presenting at ODSC. We're talking about lessons from the field in developing an ML ops strategy. So be sure to come visit that. I will drop a link for you right here in the Zoom room, as well as on the LinkedIn post that you're watching on in the comment section. Be sure to register for that. That'll be a lot of fun. So it's a great presentation. Well, I'm biased since I'm the one that created it and will be giving it, but it's a lot of fun. And what else? So later today, I'm going live later today with Marcus Dusautoy. He wrote the book, The Creativity Code. We'll be talking mostly about his new book, though, Thinking Better, the art of the shortcut in math and life. But we'll also be, getting in some questions on Creativity Code as well. Marcus Dusautoy is really, really cool, man. I really admire him and look up to the work he's done. He's the Simon E. Professor of the Public Education of Science or something like that. Some weird, long, crazy honorific title at Oxford University. But he's well deserving of it. You might have seen him on BBC documentaries and things like that as well. Then tomorrow, going live again with Danny Ma. That's at 4 or 5 p.m. Central Time, probably 4 p.m. Central Time. There is an event somewhere on my profile. Go look for that. Excited to go live with Danny Ma. Good friend. I've actually never really, we've been chatting here and there, but I've actually never had a one-on-one conversation with Danny Ma, so you get a chance to get to know each other live. And then again on Friday, going live at 4:30 p.m. for the Data Science Happy Hour. I've been going live a lot, man. This month I've been out here, man. I've been out here pushing it. So hopefully you guys have not had enough of me and want to see more, because there's a lot of me to go around. My friends, welcome. I think that's enough time for you to come up with questions. If you guys have questions, please do let me know. We're going to kick this session off with a question talking about what part of machine learning or deep learning would you like to see demystified? Is there a particular part of the machine learning or deep learning workflow or a particular algorithm or something that is kind of got you tripped up that you would like to see demystified? Let us know. I want to hear from you guys, because myself and Drew and Michael, our other colleague, will be creating content based on what it is that you would like to see demystified. So drop it right there in the comments section or into the chat here in the Zoom room. Please do let us know. Something that we got, kind of coming up in the works. I'll get this conversation kicked off, but then I would love to hear from Kristoff and Hashim, who's in the room. Maybe even Drew, if you're demystified on something or you have an idea about what the kind of content to create, let us know. And then also, if you're tuning in on LinkedIn, feel free to chime in on the comment section there. But I think it's just hyperparameter tuning, I think, would be an interesting thing. Like if we dissect the various hyperparameters of one particular algorithm and see how they affect an outcome and see how the interaction of those hyperparameters affect an outcome. So I would love to do a series on that. Maybe take a couple of traditional machine learning algorithms to start with and explore how various combinations of hyperparameters interact with each other. We can even test kind of something empirically, where we can go to the literature of the actual algorithm and see what the creators or authors of the algorithm say about what this hyperparameter is supposed to do, and then actually test it empirically to see if that has the effect that it is intended to have, and see the interaction of those various hyperparameters. I know, Drew, you've done something similar with that with light GBM. We definitely would love to recreate that, maybe do it with random forest or the new histogram gradient boosting algorithm, which I think is the same thing as light GBM. But yeah, let us know. Let's start with Kristoff. Let's go to Kristoff, and then after Kristoff, we'll go to Drew. If you have questions, please do let me know. We'll take your questions. See a couple questions coming in from LinkedIn. I see you. It's one of those standard questions about how to get into data science without having experience. I guess we could talk about that as well. But Kristoff, go for it.
So I think interesting would be to know which algorithm to use in different kind of data sets. So I'd say there is, for example, 50 plus features, and which algorithm would be the best. Because as far as I know, in machine learning, in traditional machine learning, random forest is kind of a default. It beats usually other algorithms, but I believe there are cases where other algorithms are better. So I'd like to see and know when to use which one, not always to go for random forest first. And in case of deep learning, I think it would be great to demystify, like to know based on which features the model made some predictions. But I believe that very often it's hard to interpret because it's a black box, and it's actually a bad idea trying to open that box.
Yeah, it's like a feature importance type of application for deep learning. But going back to your previous question, that I'd love to hear from Grube on this. Grube, how do you approach that first question that Kristoff was asking? So, Kristoff, let me know if I'm getting the question right here. It's okay. You're presented with a particular data set. You've done all your data models, and you've got your features set out. Features have been engineered. You've done what you have to do to prepare the data. Now it's time for you to figure out which algorithm does best. How do you even go about deciding that? This is a great question, and I think it's something that's worth discussing. I'd love to hear what Drew's process is, and then maybe I'll chime in with mine as well. By the way, if you guys have questions, do let us know in the chat or the comment section. I see you on YouTube and on LinkedIn. Thank you guys for watching on LinkedIn. Go ahead and smash a reaction on LinkedIn. I see you guys are like 20 of you people. Watch this and leave a comment to share it with your networks. Drew, go for it.
Yeah, so this is like, it's not really a trivial question because it's very hard to know beforehand like what is the best algorithm. So I'm sort of guilty of just going with tree-based algorithms. It's sort of like use what you know, because tree-based algorithms are fairly robust. I mean, if you're working with tabular data, it's like really robust. You don't have to do a lot of pre-processing. You don't have to normalize things. They work just out of the box. You can throw raw data at it and it'll give you something. They also come with like feature importance, which is also like a quick way to like just understand like what features in your data set might be giving you signal, or at least like look at ones that seem interesting. And the I guess like the additional benefit is that they're also very interpretable. It's just like splitting data at like, it's a bunch of if-else rules. So it's very, very interpretable. So I tend to just usually go for a tree-based algorithm if it's tabular data. And then like gradient boosted trees have been my preference for like a very long time. Before that, it was random forest. Yeah, like iterating on that sort of involves understanding the data better. I don't, like off the top of my head, I don't necessarily know of a case where some sort of parameterized model that is not a neural network beats out a tree-based model. I practically have not seen that.
Thanks for sharing that, Drew. Yeah, I'm partial to tree-based algorithms as well, but I feel like some sometimes I will create a data model on which I build an algorithm upon with kind of malice and forethought. Like I'll engineer features in such a way that it kind of lends itself towards that tree-based type of algorithm. But here's a link to this interesting paper here. Maybe I'll share it on LinkedIn a little bit later, but it's Leo Bryman. He's the guy who created the random forest algorithm amongst, a couple other algorithms, and it's called Statistical Modeling Two Cultures. And in there, he talks about the multiplicity of algorithms, stating that essentially for any given problem, there's a whole suite of algorithms that could perform best, right? And you're never going to be able to find the true, like an algorithm that maps one-to-one to the true data generating process, right? The real world is essentially random, and there's randomness in there. And us using an algorithm to build a model really is just our best attempt at trying to model the data generating process. So that being said, I think what's more important than trying to find like the exact right algorithm is just a principled approach to getting closer and closer to the truth. So definitely start with a baseline, right? Which is the simplest possible algorithm that will give you a reasonable result, right? Like you can come up with a baseline that, for example, classification algorithm where it just randomly predicts something. That's not really that good of a baseline, right? You can get more intelligent than that for baseline. Maybe you want to create a baseline where you always predict maybe you group by a particular column if that column presents itself with groups, and then for each group, predict the most commonly occurring class. That's a little bit smarter way to create a baseline algorithm. Or you could just go with the logistic regression type of thing, like a simple model that will give you a result. And then from there, you just slowly iterate using more and more complex algorithms to figure out which one provides the best model of the underlying data generating process. So I don't think there's, ever really the best algorithm out there. You can ensemble some together, but they're just an attempt for us to try to explain reality at the end of the day. Hopefully that wasn't too weird. I didn't say anything that will get me eaten alive by, pedantic people out there, but that's kind of my philosophy on that. Kristoff is asking, how does random forest know the feature importance? That's a good question. I think a lot of it is from information gain. Which feature tends to create the, when you split on that particular feature, which one it gives you more information, right? So we have these like metrics, Gini index, and information gain and things like that. Did I butcher that one? What do you think? How is it that random forest knows the feature importance?
Yeah, you're right. It's basically at every split, like how a random forest works is like at every split point, it picks a random subset of features, which are with repetition. So if I have 10 features, it will, and like you select there's a hyperparameter that you can tune, like how many of these subsets do you select? So like, let's say you have 10 features, like at split number 1, what it does is it will select, like, let's say 8 of those features, and then try to split the data according to those features, like based on like those if-else rules. Like if feature 1 is above 10, split this into 2 groups. And then it looks at like the error, the predicted error in the top node, and then at the the two nodes at the bottom, and then whichever node has the lowest error, it like selects that, like whichever feature produces the lowest error, it uses that to split, and then it moves on to the lower node. And then essentially like the features that are used most commonly to make these splits tend to be ranked. And that's like how you get feature importance. So that's, just saying what Harpreet is saying all over again.
Yeah, really in depth. But one thing that really helped me understand how random forest works was just a little bit of information theory. I was watching this series of courses on Amazon Prime. They have like an add-on channel called The Great Courses, and I was watching a course called The Science of Information. Only, there's 36 episodes. I think I got like 18 episodes in before I got distracted by something else. But it starts off from first principles about what is a signal, how do you extract signal from noise, and what is this concept of Shannon's entropy. And it really for me, help bridge the gap between the statistics and probability I learned in school and just real world information and conceptualizing it with random forest was really helpful. Yeah, a little bit of information theory I think will be helpful as well to really gain an intuition behind some of these measures like entropy or the Gini index, things like that, information gain. Anybody else? Hashim, I see you right here, but your camera's off. That's all good, man. But do you have any aspect of machine learning or deep learning that you would like to see demystified? And then after that, we can get into your question.
Good question, Harpreet. I am actually a total noob at the moment. I just started. So I got to know about your pod through Super Data Science, and I'm trying to learn as much as I can. Yes. Yeah. So I don't have any specific questions. Everything seems like a mystery right now, but
yeah. Well, I'll have a series releasing soon, just all about fraud detection and balance classification that'll go really in depth. That hopefully will get you an intuitive understanding, at least, of how to do binary classification in an imbalanced setting, and getting really deep on which evaluation metric you should use in a given situation. So keep an eye out for that. Yeah, Super Data Science. Shout out to my good friend John Crone. John will be coming on the podcast at some point, but him and I are connecting this Saturday. I got a phone call with him, just catching up a little bit. John, you keep poaching all of my friends and bring them onto your podcast. I think Super Data Science has had more people on their show. I've heard my name mentioned on that show at least 12 times in the last month and a half. So thank you guys for all the support. I really appreciate it, John. Shout out to Mr. Crone and his amazing book, Deep Learning Illustrated, which is right here, buried under a number of other books on deep learning. But yeah, man, good to have you here. Hashim, please definitely feel free to swing by. If you got any questions on anything whatsoever, please do let us know. We've got a couple questions coming in from LinkedIn. I think one is really pertinent to the topic we're discussing. Robert Sievert. Robert, good to see you, my friend. He's asking, how would you define best? Within the context of trying to find the quote unquote best model, that's a hard question. How do you define best? I think one that beats out the whatever baseline you have, but then yet at the same time provides predictions in a timely manner. Like you can have a perfectly clairvoyant model, but if that clairvoyant model takes 3 years to make one prediction, it's useless. So there's that element of trade-off, right? You want to have a model that provides good predictions in a short amount of time as possible as well. So there's always that trade-off. Hopefully that made sense. Rue, what do you think? How would you define best?
Yeah, best is I don't really know how to define best. I can sort of define best for right now, or best for this case. Most of that comes into like very clearly specifying like what are your expectations of your model. And if a model meets those expectations, then yeah, that's the best one. Like you want to go into like building a model where you have some sort of idea of like it needs to have this level of accuracy or this level of latency, or even like it has to be only like 10 megabytes because we're deploying it on some constrained resources. Like there are other considerations. Before you can really arrive at best.
Yeah, best is very subjective. I think whatever gets you closer to the truth in as short amount of time as possible with the least amount of error, given the context in which you're using the thing, I think that's enough to say that you found the best model. But yeah, been constantly iterating on that. Let's go to Hashim's question. There's a question coming in from Asif on LinkedIn, which I think we'll get to, but I have a feeling it might be redundant. We'll push that one, but we'll go to Hashim's question. Shout out to Matt Blaza. Matt Blaza is in the building. Always good to see you. Go for it, Hashim.
Thank you, Harpreet. So I'll just give some background about my situation. So I live in Europe, Sweden, and I'm a medical doctor, educated and finished. And I have I've always had a passion for math and interest. My favorite topic in school all the way, and then I changed and I missed it very much. So I went back to that world through statistics. I'm doing a bachelor's on statistics right now. And by chance, I found that there's actually an intersection between biology, psychiatry, medicine, and technology, which interests me a lot. And this being data science. So I discovered all those opportunities online through Coursera and all the courses that also super data science and opportunities through, yeah, there's a lot. But what I'm wondering right now, would it be a good benefit for me to continue my stats bachelor's, or should I actually do some online courses and focus on doing as many independent good projects as possible in order to succeed? So this is where I've been those days.
Definitely think it's the latter. Yeah, it's definitely the latter case. But just real quick, just to pull something up real quick. It's interesting you mentioned your, MD moving into data science. I came across this blog recently, Glassbox Medicine, and her name is Rachel Lee Ballantyne Dreo. I can't say the last name, but she's actually a MD turned data scientist, MD in computer science, PhD candidate. And so she writes a lot about the intersection of, and she does a lot of hands-on tutorials too, about the intersection of machine learning and medicine and, computer science and things like that. So I think definitely take a look at this blog, Glassbox Medicine. There's a link right there. See if you could even get in touch with her. I've never spoken to her personally. I'm not like connected to her on LinkedIn or anything like that. But this is her name, Rachel Lee Ballantyne.
Wow.
Yeah, so reach out to her to see if she has some advice to you. But you could see here that she just, she's telling you how to organize machine learning projects, and it's really cool, man. She's got a lot of really, really great resources. So to more directly answer your question, yeah, do hands-on projects, but find hands-on projects that are at the intersection of what you already know with what you're trying to learn. And I think sourcing project ideas from a website like this is probably a good idea, because you've got MD, like a lot about the human body, I assume, and medicine and things like that,
and psychiatry.
Yeah, and psychiatry. So definitely go in that direction. Another thing is my friend, his name is Chanin Nanthesimanath, based out of Thailand. He's the data professor on YouTube, and he's a PhD in bioinformatics, and he does a lot with the intersection of pharmaceuticals and drug discovery with machine learning and deep learning. So he does a lot of cool research on that intersection, and he presents his content on YouTube, like projects and stuff like that, so he can follow along.
Wow.
So yeah, I highly recommend those resources. For everybody listening on LinkedIn, I'll go ahead and drop the link right here. It's glassboxmedicine.com. Highly recommend checking her out. Rachel Lee Ballantyne Drelos. Yeah. But yeah, hands-on projects, man. Yeah, just go through the there's no real need to go back and do bachelor's in statistics. Self-learn, self-teach yourself. You definitely have the aptitude for it if you're MD, so you can teach yourself pretty much anything. So definitely approach it from that direction, and then go through some of these projects here and just try to recreate one, try to duplicate the results. Not like necessarily copy and pasting, but kind of reading along and coding. And if you got questions or you're stuck on anything, like with respect to the code or with respect to the stats or whatever, then come here and we'll try our best to give you an answer. You can also join our community channel and on Comet if you want to ask some questions there as well. So
Comet, yes. Well, I have to say something. I've been looking for another doctor who's doing data science, and I didn't find anybody. So now, really, you gave me a big thread to follow. So I'm really happy, and thanks a lot.
Yeah, definitely, man. No problem. Yeah, there's I know there's got to be more than just her. So I mean, if you reach out to her, just send her a message. Be respectful of her time, and just tell her your situation, and first definitely read through her blog and see if she mentions anyone else that you can go follow and look at their blog and get inspiration from.
Thumbs up.
Right on. Cool. All right, let's keep it moving. I guess we could take Oh, there's a lot of questions and comments coming on LinkedIn that I did not see. Robert says, to shorten a long story, the winning model for Netflix Prize was not put into production. Yeah, that's true. Christine says Coursera is an excellent resource. Tor, good to see you, Tor. It's been a while. How much source data, historical data would you need before machine learning starts to provide sensible results? I think that really depends on the type of methodology that you want to use. I mean, we use the entire machine learning umbrella, then linear regression can get by with not that many rows of data. So there's that. But yeah, it just depends on the application and the use case that you're looking for. Christine, good to see you there as well. All right, let's go back up. And I lost Asi's question, but it was something along the lines of he's not experienced. Should he first go into data science or a data analyst role? I mean, well, you can create your own experience in data science. Did you know that? Did you know that you don't need anyone's permission to download Python? You don't need anyone's permission to go find open data. You actually don't even need anyone's permission to start writing code to slice, dice, summarize, aggregate, organize data. You don't even need anyone's permission to get a pre-trained model from like Hugging Face or something like that, right? So you don't need anyone's permission. You just start doing it. So start doing it immediately. But I think a good gateway drug into data science is, in fact, a data analyst role, if that is the path you want to go down. Christine, with the hardest question ever, can you explain how time is a dynamic element when designing machine learning projects? If it is not a dynamic element, then how does it work? Damn, that's philosophical. Time is a dynamic element. So time is a dynamic element. That is very much true. And if you just work on a project, it can continue to go on for long periods of time, as is evidenced by this project I've been working on with Comet, which I was supposed to get done in 2 weeks. It took me 3 weeks. But I think the important thing is just time boxing yourself, right? Like just say, you know what, I'm going to do this thing. And on this thing, I'm going to spend an hour or 2 hours or a day or 3 days, and just time box yourself and iterate through as quickly as possible. So, I mean, I think 2 weeks is ample time to at least do one thorough iteration through a data science project. It doesn't have to be absolutely perfect, but that gives you enough to create something from data to decisions. That's all nicely connected together. But then you can also go back and update and iterate and improve. But yeah, Drew, what do you think, man? And I'd love to hear from Austin on this as well, but can you explain how time is a dynamic element when designing machine learning projects?
Yeah, I wasn't prepared to explain time, but so I don't know if this is more related to like model performance decays over time, or like how to like you were talking about how to like time box your stuff so that you get things done. So since you already talked about time boxing, I'll talk about like how models degrade over time. Sort of how to manage that. What I found useful is like if you have a problem that you're trying to model and you have a bunch of data, it's best to like first check. So there are loss curves and there are these things called learning curves. So a learning curve is basically when you take your data set and some candidate model, and then you fit it with like, let's say 10% of the data set. Then you fit it with like 20% of the data set. Like, and then you log your metric at every like at increasing percentages, right? At larger and larger fractions of your training data set. What this gives you an idea, it's not like 100% accurate, but it's better than nothing. It gives you an idea of like, first, how does your model scale with data? So does it get better with data? Like, is there a certain point, like after n number of examples, it's not going anywhere? It just lets you know that what are sort of the limits of like, because everyone says like more data is better for the model, and yeah, in most cases that's true, but there's also a limit to like how much this data will actually improve your model. So that's like, I guess, like how like having more and more data over time will affect your model. So that's like one question. The other one is I guess like drift over time. Yeah, this one is tough. Like, so when you are building a data set it's always good to sort of have an idea of like how frequently the model, like the data changes. So if you have timestamps for all that information, then you can say like, okay, like this sort of feature changes like every day, or this feature only changes every month. It gives you an idea like of roughly how often you might have to revisit your model or re-trigger your pipeline to update the model. Yeah, I think that's like sort of my tips for time.
Yeah, no, appreciate that. That's great. The very, very important concepts, model drift, concept drift, data drift. Christine says, what about the variable of time when designing the best fit model? That's an interesting question. So, I mean, if you have a model in which time is a feature, then you're probably going down a different class of models, which is time series type of models. But is your data presenting time like cyclically, or is it presenting time as like a categorical feature, right? Because if you just have time being time of day as a feature, right? It could be morning, afternoon, night, late night, whatever, on dusk, whatever. Then you just treat it as you can label encode it and treat it as any other feature, add any other categorical feature. But if you have, I guess, a cyclical nature to time within the context of your data, then yeah, you probably have to go down series models. So hopefully that's helpful. Yeah, if you're dealing with time variable that's cyclical, then is it, what type of process is it? Is it stochastic process? Is it ergodic process? Is it, I don't know, ARIMA? Like you have to do all these investigations. Luckily, at some point in the near future, we will be doing a series on time series, a series on time series. So hopefully that answered your question. Robert said he had to run, duty calls. Hey man, handle business. Any other questions from folks? For some reason, I noticed that my video became choppy, so I apologize for that. If you guys got any questions, please do let us know. No, all right. Also, what kind of cool stuff are we going to be having happening with community engagement and involvement efforts?
Man. Yeah. So we're in full. So folks maybe have seen this, maybe have not. We're in full swing with our contributor program on our sponsored blog, sponsored publication, technical publication. It's called Heartbeat, heartbeat.comet.ml. And we are open and taking submissions. Basically how it works is we're sort of targeting the data science. So these conversations are like smack dab in the middle of what we're thinking about, right? It's like explainability of different data science and ML systems, smack dab in the middle of this sort of like data science 201 and above technical content. And I think one of the things we're trying to do as a community is like build some knowledge sharing platforms, kind of understanding that like, the best practices in this industry, the ways, we can learn how to build these models better, faster, more efficiently is going to come from the ground up and from the community. So we have that program open for folks. We pay for all our contributor content. We do editorial work, but basically helping provide these platforms to help people share like sort of like how you build better models faster, how you shape your workflows, how you build projects, what you're learning from new research or new model types or new use cases, things like that. So it's pretty open. We can drop a link obviously in the chat and on LinkedIn as well, but that's one thing we're doing. We're also expanding our things like we're rethinking this session, for instance, right? It's like I think you were talking about a couple of your projects, Harpreet, and we're thinking of doing sort of like guided tours through those projects with some question and answer components there as well. We've got big plans around some bigger events that is more traditional sort of hosted event series, things like that. So also just thinking of ways that we can create sort of public, with our tool set, Comet as a sort of experiment tracking and management system. How can we create sort of public open assets that allow people to do things like explore trends in research or outputs of generative models, things like that. So sort of having also like community level resources so people can see like, hey, you know, you're seeing all these generative art projects, but what are the hyperparameters of those models? What does it actually look like? What does the code look like? What are the metrics there? Sort of giving more visibility into projects like that. So it's kind of a bunch of different things. And then also just like partnering with different organizations in the industry to sort of like grow just like this, the overall ML ops space. You know, we're seeing more division within these from data all the way to sort of monitoring models in production. So we're also trying to integrate with the sort of the right tool stack to help make our tools better, but then also feature and highlight partners in the space that we're doing some really important work that's a little bit outside of our focus at Comet, but making sure we're working with those partners as well. So it's a mix of, you know, knowledge sharing from the community, working with partners, and then putting on, you know, events and educational content series that sort of really all converge on this idea of like, you know, this kind of work. The next generation of this kind of work is there's going to be these standardized best practices. There's going to be workflows that, you know, are across industries are standardized for building these models and putting them into production. And we're sort of the idea is that we want to be spearheading the knowledge sharing that gets the industry there and supplies the practitioners and individuals like all the folks in this room right now with the tools to you know, shape that future of the industry. So that's really what we're doing. And I think right now we're just getting started there with sort of the contributor program events and then sort of supporting partners and integration partners throughout that. I probably missed some things that we've been talking about and thinking about, but that's sort of like what I've been really focused on lately. Yeah,
right on, man. Thank you. Yeah, and that's, you know, that's part of the reason why I was kicking off this session, seeing what part of machine learning you guys would like to see demystified. So if you still have not had your chance to tell us what part of machine learning you'd like to see demystified, please do let us know. We'll do our best to create content around that. Yeah, a lot of cool, fun, interesting stuff happening. I'm excited for that.
One thing I kind of was curious about, I've been seeing, you know, I think this is kind of a recent development is, and I was actually working on a contributor piece of content that'll be forthcoming in the next few weeks around this sort of shift in thinking among machine learning teams and practitioners. This understanding that like iterations to like model components, whether it's hyperparameters, optimization, compression, all these kinds of techniques, often lead to like lower marginal returns in terms of model improvements versus like really focusing on your data. So this move towards like a data-centric focus for teams and AI, and like, what do we need to do to our data sets? I don't know if anyone in this room has any insights on that, or like, I know this is sort of a new thing that's being talked about, and I know NeurIPS is going to have a workshop session this year on data-centric AI and the sort of movement that some folks in the industry are making. So I'm curious if anyone knows anything about that here or has any insights there, and what that actually means for the future of this industry.
It's been on my to-do list of things to read. I know Andrew Ng has been talking a lot about data-centric modeling, data-centric machine learning. Unfortunately, I haven't had an opportunity to dig into that. Grube, are you familiar with this topic?
Yeah, better data is definitely will always beat out a better model. Like from what I've seen, just like good clean features that makes sense, that you believe will have high signal. You could throw almost anything at it and you probably get something decent. The opposite is not true. If you have really crappy data, it's unlikely that even the best model, or well, I guess like we just talked about, like there's no such thing as best, but whatever, the most capable, most powerful neural net or largest XG boost and all the hyperparameter tuning in the world will not let you not give you anything, because there's like no signal in there.
To me, it sort of feels like this shift towards like the reality that like, you know, for the sort of history of the modern neural network, right? If you go back to 2014, 2012, like AlexNet, these sort of kind of core computer vision CNNs, like this is sort of this next wave of neural networks and things like that. A lot of the model-centric approach seemed to be really around like R&D, creating like state-of-the-art model architectures, things like that. And now I think it almost strikes me, and I'm curious if this is maybe the sense that other folks get, is the data-centric approach is really like, you know, we're kind of hitting this point where like, you know, to actually kind of realize the promises of machine learning, like businesses actually have to be able to put this into production and solve like real problems based on the data that they have, or that the data that they collect. And it almost strikes me that like the modeling R&D sort of approach, we've sort of hit the upper limits of that in terms, or some of the, or not upper limits, obviously there's always more to do, but that taking a more data-centric approach is the sort of thing that you said, like, better data is going to be better models, right? Like, to actually put things into production, the data-centric approach is going to, result in those returns on model performance that actually make a model like good enough to like put into production, versus like spending weeks and months on tuning hyperparameters to get a 0.001% increase in whatever metric. So it almost strikes me that, like, at the same time we're seeing all this talk around like ML ops and building better teams and lessons, like the things that we talk about, as a company, it's like there's this other piece of it is like, oh, the data-centric approach is kind of what maybe pushes, or is going to help push things over that finish line, so to speak. Not that it's ever done, but I don't know if anyone has any reflections on that. It just seems like it's coinciding very much with like, okay, we've done a lot of this soda model creation, and now like, how do businesses actually get value out of this in real, sustainable, long-lasting ways? And I wonder if the data-centric approach sort of meshes well with this sort of ML ops focus that we're seeing in the category definition and all this kind of stuff. That's kind of a rambly non-question, but just something I've been noticing.
I think that speaks to the need of the importance of data engineering. I feel like data engineering, and I use that term, an umbrella term, kind of, it's like the most important part of data science, I think. It speaks to the fact that, okay, without good quality data and access to it, we can't really do anything. The best model is not going to do well on shitty data. So I think that speaks to the need for increased, like, further upstream stuff, because as data scientists and machine learning practitioners, we're kind of downstream of everything. Like, we're end users of data. Ultimately, we're creating something that is based on data. So it goes back to having good processes in the real world, right? Because data is captured as a byproduct of some data generating activity that happens in the real world, right? Whether that's manually inputting data into a database or whether that's devices capturing data. But that stuff needs to be managed appropriately. And I don't know if I'm like we're speaking past each other here, if I'm talking to a different point, but I think this idea of data-centric models, it speaks to that need for increased data management, data governance, data engineering, data architecture, all the stuff that enables us to build good models, I think.
Well, I mean, from what I see is that like a lot of these new model architectures are benchmarked on data sets that have been curated carefully, like assembled and don't actually reflect, like, if you use that architecture on some sort of in the wild data set or a custom data set or something that you're collecting, and then try to put that architecture to work on that data that isn't as curated, manicured over, a decade or whatever it is. The benchmarks don't quite seem to me like maybe they don't mean as much in that context when you're actually trying to like solve a unique domain and domain specific problem, especially. I mean, I think we're starting to see like, it's stuff popping up as well around like domain expertise being essential for sort of production level machine learning. So it strikes me that like there's sort of, you hit those limits, and also the fact that some of these benchmark data sets that we believe to be hyper curated and manicured also have some flaws in them, as just I've been reading about a little bit too. So it strikes me that, there are limits when you're using the sort of these similar benchmark data sets or variations on benchmark data sets that don't actually match sort of these domain specific challenges that companies and industries face in order to create models that like actually do something that produces business value. There's a through line there that maybe I'm not connecting totally because I'm not a data scientist, but just an observation I've had and how these concepts are sort of converging a little bit.
Yeah, absolutely. I'd love to hear from Matt on this, but I know Matt Blaza, you're probably busy at work, putting out fires, writing emails. If you got anything to comment on this, I'd love to hear from you. Tor says in the comments here, maybe also consider to offer data packages from various industries for people to practice on. Not sure if I missed the timeliness of that comment. Kristoff, go for it. You had a question.
I have a question about content creation and being a content creator. And I think I'm gonna ask directly you, Harpreet, because you're like a big time content creator and you're a big personality in data science right now. And just out of curiosity, what opportunities did you get since you're doing it? Like, I know you've emceed DSGO and you've been a speaker on virtual events, but how big does it go actually for you?
I mean, I got this job because of it. I got this. I mean, that's how far I could take you, I guess. Like, I got this job because of my podcast, essentially. So I think so. It's pretty interesting because, I mean, for example, Mark Freeman. Just I like to use him as an example. Good, Mark, good friend of ours. People heard him talking during my happy hour sessions or office hour sessions. It was folks from Super Data Science, and Super Data Science reached out to him and said, "Hey, do you want to teach a Python course? You're pretty good." And so it created an opportunity for Mark, right? But if this thing didn't exist, this space didn't exist, then he wouldn't have had that opportunity. So it goes beyond just me. And I know this has happened to a couple of other people too, who have gotten opportunities to do things because they were just seen on one of my happy hour events. So it goes just beyond me, right? So it has benefited me just, in terms of the side income. Like, I've had people sponsor my podcast. I've had some paid episodes where I mean, to get on my podcast is not cheap. It's pretty expensive, right? Like, I've been transparent about this. It's, it used to be $2,500 for one episode. Then it used to be $3,500 for one episode. And now it's $5,000 for one episode if you want to come onto my podcast. So there's that, right? So a little bit of extra income, but then just I've made some, like, I mean, money's whatever, man. Like, I can always find ways to make money. It's just the cool opportunities that I've created for myself and for other people. And then the connections I've made with other people have been well worth it. I don't know if that's speaking to your question or not, but I'll pause there.
Yeah, it does. And it's it's big. I mean, the money you just mentioned it's really huge. I mean, for me, like, when you say 5,000, I know that's still a lot of work, but
Yeah,
I believe it's pretty decent per hour.
yeah. I mean, it's a process. Not everybody bites, and like, people still try to message me and try to come on my podcast for free. I'm like, all right, well, if you're trying to sell your product or elevate your brand or whatever, it's not free to come onto the podcast. But that's just one aspect of it. More so it's just been cool doing it, man. Like for, I don't know, however long after I die, however long YouTube is around for, however long all the streaming platforms are around for, my voice will be there, and there'll be videos of me talking. So 40, 50 years from now, when I'll likely be dead, my grandkids can go on to whatever version of YouTube there is and like, oh shit, that's grandpa, he cussed a lot. Like, Austin, go ahead.
Yeah, I'd jump in on this because I think I have a perspective on this. And I think I've said this before, and I don't know if it's in a session here or in discussions with you personally, Chris, but like, it's, the production of content in its various forms, and whatever form you comfortable with, whether it's LinkedIn series or podcasts or blogs or videos or whatever, right? That to one, there's a lot of work in getting in front of the right people's eyes and the consistency with that. But it is like the outcome of that kind of stuff is almost always, unless you just get lucky and strike gold, is a lagging indicator. Like, you'll see a lot of kind of things like, oh, how I pushed 1 million in traffic to my website in 30 days. And it's the same premise as these kinds of headlines we've talked about with like, become a data scientist in 30 days. It's kind of bullshit, right? Like, that's not the normal practice of this. But what I would say is it's a lagging indicator. And the story I would use is like, even as someone who like hasn't necessarily always created the content, but has built content libraries, like Heartbeat, right? Like, I started working on Heartbeat in like early 2018. It took 12, 16, 18 months, somewhere in there, to go from, we're grinding hard to publish 2 or 3 posts a day. We're doing customized outreach. We're paying people double what we, what we had planned to, blah, blah, blah. This is, back in the early days of this, getting a lot of objections from people. Like, what kind of platform is this? Like, why wouldn't I just go towards data science, et cetera, et cetera. and it's a lagging indicator, like 18 months down the road, all of a sudden, we built this SEO strategy, this sort of content strategy, a contributor program, a vibrant community around that contributor program, right? That all of a sudden, those pieces start coming together. Other people start linking to your content. They start putting it in their newsletters. You start getting these network effects from the content you're creating and sharing, right? Where, 18 months down the road, we're at, 200 and something page view or visitors a month, right? 200,000 something page visitor, like on Heartbeat, right? Just from doing that grinding work of just like knowing it's going to pay off and trusting it's going to pay off. What I would say is that like, it's just, we're awash in content, like just as a society, it's just like, it's all just pulls to get attention. Basically, it's like whose attention can you get and when, right? And that's sort of the cynical way to think about it. But the other side of that is like, it's not a vending machine. It's like you have to do it with like pure intentions around learning new things, meeting new people, supporting their journeys, sharing what you're doing, all these kinds of core values that you hold around the content, and then in the downstream effects of that are you can find ways to monetize your work, whether it's through podcasts or through getting a new job or through, finding a paid contributor program. I mean, I know it's not what we do at Heartbeat isn't the most lucrative, or it's not a king's ransom, but I mean, it's these opportunities start to present themselves as you become more consistent and more visible, because you're able to find these pockets of like where you can, like you're talking about in the like Mark did, sort of talking on your sessions, like finding these pockets where you can kind of commandeer or at least capitalize on people's attention, even if briefly, and you just start to become more a part of these conversations, just like Heartbeat became more a part of the technical machine learning, contributor-led blog kind of things. So the things I say is like, it's a delayed mechanism. It's like always delayed gratification, almost always. And then it's sort of it's not a vending machine. You have to kind of input real, genuine value systems inside of it. Like that's the only reason I've had any success with something like Heartbeat is that I care about I just do. This is what I care about. Like I care about the contributors. Like I care about their progress. I want to see them get jobs, their dream jobs. I want to see them, put together a portfolio that they can put in front of a hiring manager. And the output of all of that genuine sort of input is something that I'm very proud of, even if it's not like, the highest trafficked blog of all the blogs. There's real genuine community level value there. And I think so it's the delayed thing. And then it's not a vending machine. And so you have to approach it with these real values that isn't around, you can have this sort of goal of like, I want to get a job or I want to become an industry leader, but you have to want to do that for actual principled reasons beyond just like, I want power and influence. Cause then it's just not, that's not really, I don't know. And it doesn't strike me as obvious. Also you personally, Chris, it doesn't strike me as how you would want to approach things either. So I think understanding that it's not a direct input output sort of situation. It's much more of a network and a collective over time that builds these things.
Go for yourself.
That's a lot. I just want to mention your point about delay, like it's a delayed process. Today I read this sentence that many beginners as content creators think like employees and they want to be paid upfront, but in fact this is the kind of activity you're doing when you get paid after, and very often like months or even years after for your hard work. So I love that point and I completely agree. And about the value you have to bring, that's also extremely important, because if you do it for money, then you burn out, and that's no other way actually.
Mm-hmm.
So thank you.
Yeah. So like I started my podcast initially because I found myself the head of a data science department and I had nobody to turn to for questions. And I was like, shit, let me just reach out to people and say, I've got a podcast. Let me ask you a bunch of questions with the really questions that I had to help me. And I was like, all right, let's pretend like I have a podcast now. And that's pretty much how it started. That's how the Artist of Data Science podcast started. Was I had a bunch of questions, didn't have anyone to ask them. So I said, let me make a podcast and ask the questions. And then it turned into something different. Right, to just talk to people who wrote books. But yeah, it's a lot of effort, a lot of work. It's just like entrepreneurship, right? Entrepreneurs like lead every day, right? They're putting in tons of hours. They're, risking a lot of their time, a lot of their capital, and the output's not guaranteed, but they're doing it because they love it. Austin, go for it.
Yeah. And I just say you never know who's really paying attention or at what time, or who's going to stumble upon what you've done now or in the past. Like the thing you wrote 6 months ago might not, someone might stumble upon it and be like, this is the exact problem I was trying to solve. Let me like bring this dude on as a consultant, or let me like talk to this person, or let me reach out and see if they want to write for my blog. Right. So there's that also that time delay and like who notices you. I mean, I think about like Heartbeat, right? Like I didn't know, but at the time, like apparently Comet was paying attention to what we were doing at Heartbeat, right? Like apparently the team at Comet was like somehow circulating this internally, or the CEO had, our CEO had identified Heartbeat as something that they would want to model a community effort off of as well. And lo and behold, right around the time I'm starting to think about a new opportunity, who drops into my LinkedIn DMs, but the CEO of Comet, and then you flash forward a couple of months and boom, I'm the head of community at Comet. It's like, it's sort of that thing too. And it's like, it's not that I wrote some one article that got all this millions of page views and then that converted into this and that and the other. It's that I had this long body of work and put in the time and the years, literally years. And the payoff didn't come until another organization would say, hey, we want to scale up our community and content efforts. Like, you're the right person to do it because we've seen that you've done it over this span of work. So if you become this industry sort of leading voice over, months and months and months, then the fruits come to bear in one way or another. It might not be a job. It might be some sort of consulting or this or that or the other, but like, that's how I would, that's kind of how I would frame it, is like, just that's the experience. And then Heartbeat, same thing. It's like you spend time and time doing this office hours for this. And then boom, the time comes when we're ready to expand our community and content teams. Like, who's the person I'm going to call? Heartbeat, because I know I've seen this proof across all of his different content efforts. That's the thing I'm talking about when I talk about the delay.
Yeah, absolutely, man. Great question, Kristoff. I guess we can begin to wrap it up. Don't see any other questions coming in through LinkedIn or any other comments. Thank you, everybody, for joining in. Appreciate you guys swinging by. Drew, thank you as well for swinging by. Let's go ahead and wrap this up, my friends. Remember, you got one life on this planet.